Hey guys, welcome. Yeah, so several months ago, 11 to be exact, time flies, I made a couple of videos with the title Fun Challenging Algebra Problems. So I have parts 1 and 2 already out from 11 months ago, and I thought I'd resume this video series now as I found a number of fun questions. So this video and the next several are going to be about fun challenging algebra problems. All right, let's look at this first one. And by the way, because all of these problems would be good contest math problems, I've titled it both Advanced Algebra and Contest Math. Okay, so here's part 3, which is figuring out what this quantity will be when 1 over x plus x is given to equal 2. So given that 1 over x plus x equals 2, we have to figure out what number this here is. Well, since we see that we have higher powers on x, a good first attempt is to square the given quantity and look at what happens if we square the given quantity. Well, on the left side, we'd have 1 over x plus x all squared, and then on the right side, we'd have 2 squared, squaring both sides. And of course, on the right side, we have a 4, but what is this left-hand side? Well, it's a binomial square, so if we use this binomial square formula, then with a equaling 1 over x and b equaling x, we can see that the left-hand side of this here is, which is this, is going to be that there, right? It's going to be a squared plus 2ab and then plus b squared. Okay, and it's still equal to 4 on the right-hand side. And now we can simplify this here a little bit, and here's how exactly. First, we can write that 1 over x all squared is just 1 over x squared, and then 2 times 1 over x times x is just 2, and then x squared is x squared. Cool. And again, these three terms, 1 over x squared plus 2 plus x squared, still equal 4 on the right side of the equal sign, yeah? Okay, now, with this last equation, which is 1 over x squared plus 2 plus x squared equals 4, we see that instead of it, we could write this, which is simplify to 1 over x squared plus x squared is equal to 2. That's subtracting 2 from both sides of the last step. Yeah? Okay, cool. So it looks like 1 over x squared plus x squared is equal to 2, just like 1 over x plus x was equal to 2. This is strange, okay, but we don't just need terms involving x squared, we need terms involving x to the 4th and x to the 8th and so on. So let's square this very last equation we just showed, which is 1 over x squared plus x squared is equal to 2. If we square both sides of it, it will look like this. Yes, you probably see where this is going. And if we use the binomial square formula, we can write this here in place of the left-hand side. And the right side, of course, is equal to 4. If we simplify the left-hand side, this is what we get. And subtracting 2 from both sides of this very last equation I showed, we could write this. We see the pattern. So, just like how 1 over x squared plus x squared was 2, turns out that 1 over x to the 4th plus x to the 4th is going to equal 2, so long as we start off with 1 over x plus x equaling 2. So, predictably then, we know that 1 over x to the 8th plus x to the 8th is going to equal 2, and 1 over x to the 16th plus x to the 16th is going to equal 2. And we see that the same powers of x, one in a denominator and one with no denominator, make good pairs. So if we pair them up that way, we've got 2 plus 2 plus 2 plus 2 plus the original 2. That makes 10. Yeah? Cool. All right. I hope you enjoyed this, and keep watching. 5 more to come. At least today, 5 more to come. All right. Take care. Bye.